Homework 12, section 6.2, combinations in the binomial distribution, video 5. So now let's answer the question, what's the probability that we're going to pass? Meaning the probability that we answer 7 or more questions correctly on a 10-question multiple choice if we have a 25% chance of guessing a correct answer on one particular question. In order to calculate the probability that capital X is greater than or equal to 7, we need to think about this in terms of what X can equal. To be greater than or equal to 7 in this context means that we want to know the probability that X equals 7, or X equals 8, or X equals 9, or X equals 10. Now, we had a rule for OR probabilities earlier. When it was two events, it was kind of a long formula. It was the probability of the first plus the probability of the second minus the joint probability of both of them happening at the same time. We didn't really talk about a longer formula for more than two events unless they were mutually exclusive. But think about it. This event that you get 7 correct, this event that you get 8 correct, this event that you get 9 correct, and this event that you get 10 correct are all mutually exclusive. You can't do two of these things at the same time. You can't say, I got 8 of them correct, oh, and I also got 10 correct at the same time. Because they're mutually exclusive, that means that we can find this long OR probability by just adding each individual event's probability. So the probability that X equals 7, plus the probability that X equals 8, plus the probability that X equals 9, plus the probability that X equals 10. And each of these is a binomial probability using this formula up here. The n will stay the same on all of them. There are still 10 questions on each scenario. The p will stay the same, it's still 25%. The 1 minus p will stay the same, it's still 75%. The only thing that's changing is this x, and as a consequence, this n minus x. We already calculated the first one, but let's just go ahead and set it up one more time. The combination in front is the total C, the number of successes, which for this one is 7, times the probability of success, 25%, raised to the number of successes power, which was 7, times the probability of failure, 75%, times the number of failures. Well, if 7 out of 10 are successes, that means that 3 more are failures. So there's the setup for the first probability. And then we got to do the same thing for the rest of them. For probability that we get 8 correct, it would be 10C8 times 25% to the 8th power, because now we're having 8 successes, times 0.75 to the 2nd power, because now if we have 8 successes out of 10, that means we have 2 failures. Hope I have enough room here. For x equals 9, we have 10C9. Out of 10, we want 9 successes, times 25% chance of a success, and we need 9 successes, times 75% chance of a failure. If we have 9 successes out of 10, there's only 1 failure. Plus, I'm going to erase the question, just the last line. The probability of 10 successes is, out of 10 questions, we want a combination of 10 successes, times the probability of a success is 25%, and we want 10 successes, and the probability of a failure is 75%. But if there are 10 questions and we get them all right, that means that there are 0 failures. And now we just get out a calculator. Well, I take that back. If your calculator does not have a combination button on it, then you'll have to work out each combination manually. If you have a TI calculator, graphing calculator, it does have a combination button on it somewhere. Text me individually and I'll let you know. And if enough of you do, I'll fill up a real quick video, grab a TI calculator and show you. In fact, there are non-graphing calculators that can do combinations. If you send me a picture of your calculator, I can tell you whether or not it can do a combination without resorting to the formula. But let's go back to the formula. We already calculated that 10C7 was 120. So how would we do 10C8? Well, the formula for combination says first number factorial on top, second number factorial on the bottom, difference factorial on the bottom. The difference is 2. The factorials are pretty predictable. It just says multiply from this number all the way down. So we'll go 10 times 9 times 8. And I'm going to use some ellipses just to leave out the numbers all the way down to 1. But if you were to write it out, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Downstairs we have an 8 factorial. I'm going to start it with an 8, but it goes all the way down to 2 and 1, just like the other 8 up there did. And then we have this 2 factorial, which is just 2 times 1. Now, why did I not write out all the numbers? Because A, I know what numbers they're representing, but B, I'm not going to multiply everything. I'm going to cancel what I can. Everything from 8 down cancels with this everything from 8 down. So there was never really a need to write it all in the first place. They were destined to take each other out. What that leaves me on top is 10 times 9, which is 90. On the bottom, it leaves me 2 times 1, which is 2. 90 divided by 2 is 45, and I didn't even need a calculator. It gets better. When you do 10C9, you have 10 factorial on top, 9 factorial, and 1 factorial on the bottom. 10 factorial starts with 10, and then 9, and then everything down to 1. 9 factorial starts with 9 and goes all the way down to 1. 1 factorial both starts and ends with 1. The 9 factorial will completely wipe out most of the top, leaving me 10 on top of 1, which is just 10. Excuse me. And then 10C10 is even easier, because the top is the first number factorial, the bottom is the second number factorial, and then the difference factorial. Well, 0 factorial by definition is 1, so 1 times anything is ignorable. And now we have 10 factorial over 10 factorial. That's just equal to 1. So you can actually knock out the factorials fairly quickly if you understand, the combinations fairly quickly if you understand all that a factorial means is multiply from this number all the way down to 1. And because you're stacking them on top of each other, there's always going to be some massive cancellations. Just gather up what didn't cancel and proceed. So moving forward, we have 120 times 0.5 to the 7th times 0.75 to the 3rd plus 45 times 0.25 to the 8th times 0.75 to the 2nd plus 10 times 0.25 to the 9th times 0.75 to the 1st plus 1 times 0.25 to the 10th times 0.75 to the 0. Real quick algebra review. Any number to the 0 power is equal to 1. Except 0 to the 0 power, but that's talked about in calculus. Any number to the 0 power is 1, so this part over here is ignorable because it's just 1, as is that one. Let's calculate all 4 of these multiplication problems separately, and then we'll add them together. I believe we already calculated this one to be 0.0031. If we calculate the second one, 45 times 0.25 to the 8th power times 0.75 to the 2nd power. You thought this one was a small percent. 0.0004. I get the feeling this next one is going to be so small that it rounds off to 0 when you round it to 4 decimal places. 10 times 0.25 to the 9th times 0.75 to the 1st. Yep. 0.000. You know what? I'm going to take these to 6 decimal places. 0.000029. Don't worry, I'll go back and pick up this one. To the 8th. 0.75 squared. So to 6 decimal places, this one was 0.000386. And then I guess I should go back and do this one real quick. 25 to the 7th times 0.75 to the 3rd. This one to 6 decimal places is 0.003090. And then the last one, one, 2, 3, 4, 5, 6. Okay, to 6 decimal places is 0.000001. So you can see the probability of getting 100 if you just guess for it random. So the probability of passing is the sum of all these. 0.003090 plus 0.000386 plus 0.000029 plus 0.000001 for a grand total of 0.003506, or as a decimal, 0.3506% chance. So you have about a 1/3% chance of passing if you just randomly guess the answers to 10 multiple choice questions where you have a 25% chance of guessing correctly. Moral of the story, study for a multiple choice test, don't just guess.